All right, let's get something done. Good afternoon, Ben.
Really easy.
Hello.
Hello.
Hi. I'm here.
Yes, you are.
No, you do. Yeah, but this proof is longer. So I have to make it. See, I'm 5 blocks tall.
Just because your proof is longer, that just means you didn't do it and
You weren't very efficient.
No.
Allie,
so
you were absent for 5th period?
You were saying that he's 11 and
I was
13.
downstairs for the dress rehearsal.
He marked you absent. You shouldn't have done
You were
that.
saying that he was 11 and I was 13. 13 is longer.
How dare you be absent?
Because that just means that you were not efficient or smart about doing it.
No, he's saying that he was proof 11 and I was proof 13. No, not that I wasn't efficient about it.
All right, any questions on the homework?
No. None for me.
Nothing? All right, here we go. Now, 1 through 7 said name the similar statement. So you got to have, I'll call it out. Remember, it can go a bunch of different ways. And then state why they were similar. All right, number 1. Now, this is the book answer. You can have your letters in a different order. However, B has to go with E. So BAC to EDC is the book answer by SAS. Number 2, C has to go with J. So CAB to JTH, angle. Number 3, L has to go with N. LKM to NPO, SAS. Number 4.
Wait, for 4? No, 3.
4, C has to go with N. CAB to NXR, SSS. Number 5, A has to go with A. ABC to AEF, angle. And 6, S has to go with C. SRA to CBA, SAS. The other class didn't like the table. The table, every one of those is SS. They don't ask you why. It's SSS. Yeah. So this is the one thing we did in class where you had to pull out your calculator. You just had to make sure that things were proportional. And it was all 3. Some of you could because the numbers were nice and friendly. I don't know, 10, they're not so friendly. 7, yep, they're proportional. 2 to 3 or 3 to 2, either way, depending upon if you did big to small or small to big. Number 6, they are not proportional. I'm not sure why, but
Number 8,
Number
8, yes. 8 would be what 2 to 4. I'm sorry, 3 to 4. 10 to 12 would be 5 to 6. Okay, so clearly not.
Well, no. It's ABC. It's ABC to TRI. So.
Oh, I got you. So the 6 to 12 with a half,
and
but 8 to 22 is not.
No,
half.
8 to 16.
Yeah. And that would be a half, right?
But it would come down to 10 to 22.
And that's not a half.
Yeah.
Right. All right, number 9, 2 to 5 or 5 to 2. 10 is 4 to 5 or 5 to 4. All right, I'll look at your proofs. You guys did the proofs okay?
I did, so.
All right.
Yeah, they weren't that difficult.
No.
All right, that was it. Somewhere in my stack of stuff here.
Only one way to prove this. We need to go to a lava bank, and then one of us needs to see who gets to the high ground first.
Oh, what?
I would lava bank.
I finally watched episode 7 or 8 of Mandalorian.
Don't spoil it.
And at the very end, they're going up the lava river. I didn't spoil anything.
The first season.
First season.
Rip droid.
La, don't spoil it. All right.
I mean, you learn about the droid in the same episode, so. It's not.
Well, you had him in the episode. You had it in the episode before that as well. Too. You had
No, because of the thing that happened is different. Different.
3, but the droid had been in at least 3 other episodes.
Yeah, but they were different.
Yes, I understand why.
Different.
All right. Oh, that's a big mess. Ben, I don't know if the other teachers have told you this, but you must.
Yeah, I know.
This is for 10th grade. We don't have chemistry, and we have
How am I on the wrong? Oh, I know why, because I didn't change it.
you up here.
All right, so ignore this. This is not the droid you're looking for. Wow, how did I mess this up?
A lot.
I thought I got this right over the weekend. Clearly I didn't. It does reflect, though, the basic scheme maneuver. All right, but for Madison, obviously, Madison, this is not your schedule. I'll have the right one up by tomorrow. But the thing that Ben says he already knows is that all of your tests, you must take them on the day that they are scheduled. So right now, if you wanted to do this homework tomorrow, I'm talking on a Monday, if you turned your homework in, or you did your homework on Tuesday and turned it on Wednesday, you'd be good to go. But next week during semester final, whatever that final is on Monday, you got to take it on Monday. Whatever the 2 on Tuesday, you got to take them on Tuesday. You may take them at 90-minute intervals, whatever time during the day you want them to, but they got to be turned in by midnight. All right, homework tonight.
You underestimate.
All right, here we go. I've been telling you that for a lot of people, this is a hard chapter. It's mostly because of today. Today, there's like 3 different things that we're going to do. They all have the same basic theme, but they're different, and there can be some confusion. I was never confused on this stuff. It made perfect sense to me the first time I was shown it. But after teaching it many years, I find a lot of students get hung up on this, when in fact, it's if you follow a pattern and complete a pattern, it's pretty simple. All right, I'll try to slow down when I can go over that. Today, it's all about the patterns. If you can identify a pattern or follow a pattern, you'll get it. It's pretty simple. If you can't identify a pattern or follow a pattern, you don't get it. Watch the pattern. I got 2 segments here. I'll call this a short segment, AB, and I'll call CD the big segment. Here's the pattern. A over L over B. Guess what the next thing I'm going to say is?
Is equal CM over MD.
And that's the pattern. Can you follow that pattern?
Yeah.
A over L over B equals C over M over D. That's the pattern. So we're gonna give this a name. When that is true, we call that the segments have been divided proportionally. Okay. I don't say put this in your book of truth. I'm going to use this word divided proportionally in the 3 theorems that we're going to do today. Well, it's actually 2 theorems and a corollary, but it's 3 new rules that we're going to get. So when we say things are divided proportionally, that means you can make a proportion with them. When you make this proportion, it will follow a pattern. And today is all about, can you follow a pattern? Can you continue the pattern? And if you can do that, then you're not going to be confused by anything I will do today. But boy, are there a lot of patterns. I mean, a lot of patterns. I'm not even going to show you all the patterns that you can make. I'm going to show you most of the patterns. The 2 segments, notice there's nothing about somebody being in the middle or anything like that. We're just saying if you can set them up in a proportion, we say that the segments have been divided proportionally. Okay, now, I don't think there's actually any questions on segments. It's all going to be on triangles and other shapes. Here's a proof. All right, we've done a proof with a shape like this before. PQ is parallel to RS, and RST is a triangle. All right, that's all you're given. You're asked to write this proportion right here. And notice the pattern. Everybody look at the board. The pattern deals with the left side of the triangle and the right side of the triangle, nothing on the bottom. So the pattern goes RP over PT. What will be the pattern on the other side?
Is TQ or SQ.
They're asking you to prove that the 2 sides have been divided proportionally, right? It's just following the pattern. It's literally this pattern right here, except it's on a triangle. So RP to PT, we're trying to prove that it's equal to SQ over QT. Okay. That's my statement. That's where I'm going. It's going to take all this to get to the answer.
That's not too much. All right,
That's the whole page.
all right, so first we can prove that the triangles are similar.
Yeah, we could do that, right? Because if that's parallel, then we would have corresponding angles here. So clearly,
I mean, we only really need to do one corresponding angle, so then it can be reflected with these. Then I mean,
oh yes, that's true. All right, the book decides to do this, okay? Which is what we literally just said, right?
okay, yeah,
Okay, so if that's the case, then what did we say?
that the triangles are similar.
So what do you want me to say?
TPQ is similar to TRS.
All right, I'll buy that. I didn't name them like that, but okay so far?
Mhm.
If that is true, we can immediately write a proportion.
All right, RT over PT equals ST over QT.
Right. So he went long or big triangle to small triangle is big triangle, small triangle. So he said RT to PT, ST to QT. No, that's true.
Okay, and then if
Okay, hold on a second. All right, McKinley, what's the difference between the proportion we just wrote and the one we're trying to prove? You can look there as well. Same thing. What's the difference?
all right, the numbers are kind of mixed up. Like,
What do you mean the numbers?
R and P should go together, and P and P should go.
So our problem is that where we're going says RP and ours says,
RT.
we got to get rid of an RT. It also says, oh, that's it. We get rid of this RT, change it to an RP, we're there. So where's RT?
We could just blow up. No, we just change ST to SQ.
Oh, I'm sorry, yes. There are two things. And then ST, we got to change to an SQ. The rest looks good, though. So,
We need to do segment addition to it.
well, RT is the whole darn thing. And Jack says that
Or we could say the RT times.
we could say something about RT, right?
Yeah.
RT is made up of,
two segments, RP and PT.
and we could say something about ST. Okay, well, let's try that. And then this says RT, so we can immediately write.
RT.
RP plus
And this says ST, so we can immediately write.
SQ
SQ
plus
plus
QT.
QT.
Oh, and then we have that same
Flip your page.
what do you mean?
Flip it. Find it.
Theorem. No, not theorem.
It's not a theorem or a postulate.
It's a property of a proportion.
It's
1D, I think.
it's one something. I think it's 1C. It might be 1D. I think it's 1C.
1D.
1D. All right, here's what 1D says. Check it out. There's an equal sign, right? What's PT over PT?
PT.
No. What's QT over QT?
1.
So all I've done is add 1 to both sides. We'll subtract 1 from both sides, and what will you be left with?
RP over PT.
And that's what we're trying to go. So this is whatever that is, what property of proportions. You don't have to say 1D. Okay, cool. What do we just prove?
That if you have a triangle with two parallel lines inside,
One, but
then
that there's a line parallel to one of the sides.
then the two sides are divided proportionally.
Are divided proportionally. This is 7-3, right? 7-3, yes, 7-3. So 7-3 says that if a line is parallel to one of the sides and intersects the other, it's got to intersect the other two, obviously. Then it divides the. Now you got to be careful about which sides they're talking about. We're talking about this side, right side, and the left side. So it divides in proportion. And just like we did on that box number 1, we go RP to PT. It's congruent to SQ to QT.
Wait. Are we given that RP equals SQ?
Nope. But it doesn't have to be. Watch this. Right triangle, right? Is this going to equal that?
No.
So it doesn't have anything to do with equality. That's proportionality, though. If it's an isosceles triangle, it'll be true. Well, then we would have to caveat and say that the two sides are the left and right one. So how about this? How about it's an equilateral triangle? Then it's absolutely true. Because it could be an isosceles triangle, but the two congruent sides could be the right side bottom.
Oh, yeah.
And then it wouldn't be true.
Mr. Terry,
Mhm.
you missed an A in triangle.
Yeah, period 2 caught that. They didn't catch any of the logic, but boy, did they catch the fact that I said tringle.
They're like, I don't know what this means.
I don't know what it means, but you misspelled triangle.
If I become a math genius, does that mean I get rich or no?
Some math geniuses get rich. If you are a math genius, let's just say there are plenty of opportunities for good paying jobs.
Like what? Calculator maker?
The one that everyone likes to throw out is a statistician, or an actuary is the other one that always people throw out. I'll just say I have a friend that I went to college with, and he has exactly the same degree as I make. He's not a math teacher; he's an actuary scientist, and he makes way more money than a teacher does. But he also has to deal with that stuff on a daily basis. So if that's what floats your boat, then great. Actuaries do lots of things. One of the things they figure out is how long are you going to live, right? And so they derive mathematical equations that basically predict how long a population, not a person, but how long a population will live. We predict that the people who are overweight and have type 2 diabetes will live to 62 and a half. So when someone who has overweight and wants to get a life insurance policy, right, then they calculate how much that person should pay so that the insurance company can still make money. And that's what they do. And it's a well-paid job. But like I said, to me, that sounds kind of boring, but.
I love this thing.
All right, so the but here is this. The but here is that, what is this thing right here? And what do we learn in section 1? That's the but here.
That if you have this, then you also have.
You got a lot of things. If you have a proportion, you get lots of things. And the but here is this, is that we can say this a lot of different ways. Here's one way of saying it, right? Watch this. This is the one that we just did. So we got B to A, and that would equal
C to D. No, D to C.
You got to follow the pattern. B to A would be
D to C.
C to C. But I could flip this whole thing over, right? And say A to B is C to D.
Then you could also use the segment addition function to make a bunch of other
And
ones.
then I can flip the whole thing sideways. I could say, write this, I could write it like this, right? I could say B to D. Now I'm going B to D, that's got to equal
A to C.
That seems weird. We shouldn't be able to do that, but all I did was take this. That's 1B, I believe. All they did is take this original one, right? And simply write B to D is A to C.
Yeah, there's
Either that or else I'm having a stroke. Okay. But here's 3, but there's more up there, right? Check it out. We showed that in this basic construction, that in fact we just used the proof that this triangle, that point in the small one, Ben, is similar to the big one. So we could also say
B to J is B to K.
no, not B to J, but no, it wouldn't be. Is this part right here?
J to A
We could say J to A
is K to C.
is K to C, or we could say A to J is C to K. So we got that. And then all the way, I'm not going to do them all, but all the ways you could say that. There's one that I'm not going to show you, and it is what you just tried to do. And it is B to J. This is one of the ones you'll have to more prove. But B to J is equal to D to K. Basically, any way that you can, I mean, give me any letter that's up there right now.
B.
B. I can go B to A, I can go B to J, I can go B to D, I can even go B to K if I want to. B to K would be the same as B, follow the pattern. B to K would be the same as
D to J.
D to J. As long as you follow the pattern, you're okay, it turns out.
Can you not say B to C is congruent to A to D? Or
Absolutely can say that, right? All right. So this is the problem, is that because you can do all of that, I lose. By the way, this is the first one. We got two more. All right. But I do want you to notice what's the shape.
A triangle with two parallel.
A triangle with a parallel line that intersects the opposite two sides and is parallel to the third side.
It's going to intersect with the line.
Okay. All right. So that's the first one. So how do you use this? Well, kind of like what we just did. You pick a pattern, you follow a pattern. All right. So what is that? They're going to give you, obviously, tonight for homework, some numbers. All you got to be able to do is follow the pattern. All right. They set you the pattern. This sets the pattern. So McKinley, what's the pattern?
Tn.
There's Tn.
Over NR.
Well, there's NR. So what's the pattern? With numbers now.
Oh, 6 over 3.
Okay, what was the pattern?
Sorry, 3 over 6.
You got to follow the pattern. So we would say SM to MR. In other words, we would say 3 to 6 or 1/2. It's just the ability to follow the pattern, right? Anna?
It'd be TR over NR, so SR over MR.
Which is?
9 over 6.
9 over 6, right? Which is 3 over 2. Jack?
Yes. Rn over RT. Rn over RT equals Rn over Rs, which is 6 to 9. Which is 2 to 3.
Okay. No big deal. And if this is where the class ends, none of my students would be confused. The problem is we get 2 more of these things. I'm going to give you another shape that kind of sort of looks like this, but is not this. And I'll give you a third shape that kind of sort of doesn't look like this, but is like this.
Oh, okay.
All right, so here we go. So today's just about, can you recognize pattern? By the way, also for homework, they may give you a proportion where there is an x involved. You got to solve for x. Okay, but it's going to be a proportion. It's not too hard to do. All right, let's see the next shape. The next shape looks like this. I don't know how you want to describe this, but there's no triangles, right? I got 3 parallel lines cut by 2 different transversals. So 3 parallel lines cut by 2 transversals. It kind of looks like exactly what we're trying to prove. Last time we were trying to prove that some proportion is equal. We're doing the same thing. What's the problem with this picture, though? There's 3 parallel lines, and there's no triangles.
Okay, got it.
Don't look through the book. Oh,
I just thought of it.
Don't look through the book.
I recognize.
don't look. It gives away the whole proof.
I didn't look at the proof. I just was looking back.
McKinley, our problem is
You're allowed to
we
think
don't have triangles. So how are we going to solve that?
You don't need triangle.
We actually do, but
The way it looks basically like a triangle. You can just create one.
we could create one. Okay, so one thing we could do is extend these lines, and at some point, I don't know, there's a Z up here where the 2 lines come together since they're not parallel. Okay, I'll buy that.
That's one way to do it. Do RS
Okay, we're not gonna do that route.
equals X.
We'll save that one for the last proof.
But that works. I just solved the proof.
I'm gonna reject his triangle, although it is a triangle, and ask you to make a different triangle.
But my triangle worked. I solved the proof. I win a gold star. Oh, okay.
There's an easier way to make triangle here.
I guess you can make RY a triangle.
Okay, I like that idea, but let's even make it a bit more general. Instead of going from R to Y, let's go from R to
Z.
Okay, I'm going to reject that one, not because it will work perfectly that way. The book you chose X to T. but it's the same proof. It would work going exactly the same way. We're gonna make this auxiliary line x to t. Now notice we got lots of triangles, right? Okay. Notice there's no space here. This is how easy this is done. What did the previous theorem say? If
Yeah, one side of the triangle intersects the other two sides of the triangle. Then the line.
One parallel line.
Yeah, there we go.
I'm going to cover up this part of it. Do you see it?
Yep. Yeah.
It's exactly 7/3. So what's the proportion I can write?
Xn over nt equals. Wait, move your hand.
Xn over nt. Keep going.
Oh, well, okay, equals rs over st.
See what he said?
I was doing it the other way.
Well, we'll do that second. Let's do this one first. So he said Xn over Nt equals Rs over St. Okay? Perfectly fine. The book just chose to write it like that. So instead of going from that to that, they just went Rs, St, Xn, Nt. Okay? All right. Take my hand. Allie, do the same thing for that triangle.
So,
Why would you?
You'll see in a second.
so xy over yz equals en or xn over nt.
They just chose to write in a different order.
Okay, got it.
Okay? So that's what she said.
Then you just do the substitution.
McKinley, what's that say?
Xn over nt.
What's that say?
Xn over nt.
So what could you say immediately?
They're congruent or equal to each
What are equal to each other?
other. Xn and nt is equal to xn.
Okay, that's reflexive, but I'm looking for a little bit better than that.
But I'm right. You're right. I'm
Agreed. What can we say?
We can do substitution.
And say what?
So that RZ over ST equals XY over YZ because
Yeah, it's RS, not RC. But yes, she's right. So all we're going to do is a substitution and we're done. By the way, it's messy. You can't really tell what we're doing. So this basic construction where you have three parallel lines, by the way, it could be 4, 5, or 6. Three parallel lines cut by two different transversals, that the two transversals are cut proportionally. So this came directly from what theorem?
Theorem 5-9.
Theorem what?
Theorem 7-3.
So we're going to call this a corollary to 7-3. So this one doesn't get a name because literally all we did was draw one line and call up 7-3. That's why this one falls off directly from that theorem. So we're going to call this a corollary to 7-3. Yeah.
I'm wondering how is it xy to YZ? Wouldn't it be xy to YZ?
Yeah, that's what it is.
But on
It's
the,
X,
Oh, yeah,
Y,
yeah.
Y,
on the
Z.
middle,
So that should be a Y, correct?
Yeah.
Yeah, okay. That's a formatting error. All right, so write this down while I fix my slide. Ben, I'm gonna fix my slide here a second.
Okay, that's fine.
We're not frozen. Yeah, we're not frozen.
I know you're not, but Ben is seeing what I'm doing.
Yeah, I can see that information.
Oh, I didn't freeze it? Oh. I thought I
No, it
froze
doesn't freeze on Zoom.
I know,
can
but
see
I
it.
also didn't freeze it in real life either.
Oh, wow, good job.
Three.
And although it does say three parallel lines,
What did you also say?
it can be extended to more than
Wait, can
three.
you go back?
Let's copy it down first.
Where?
And then I will forget to change triangle to triangle, and I'll be told about it next year.
Just change the T to T.
I usually catch most of them. I mean, like the mistakes that people tell me, I usually update them all, but the other one was caught during the second period. I still haven't changed.
Wait, didn't you just?
I changed the YZ thing. I didn't change the triangle thing. Now remember, this is just one way of saying it. Lots of different ways of saying it.
Wait. I have a easier quick too.
We could say RS to
Yeah,
XY,
we could, well, what do you mean?
and that would equal,
ST to Y.
see what I mean? Lots of different ways.
Wait, I just have another way to prove it.
All right, what's your way?
Couldn't you say RS equals XY and ST equals
How can
YZ?
you say that?
Because of theorem 5.9. If then it's cut equal.
No. If these are cut so that they're equal. So if RS is equal to ST, then you are correct.
Wait. No,
RS would have to equal ST. Go ahead, keep flipping.
wait. Then could you do the number?
If a transversal cuts parallel lines into equal parts, then any transversal will be cut into equal parts.
If three parallel lines cut off congruent segments on
Congruent segments.
then they cut off congruent segments on every.
Right. So we're not claiming that RS equals ST. But if it does, then you're right.
Well, I'm not saying that RS equals ST. I'm saying
Yes, you
RS
did. You
equals
just said
X.
it.
I said RS equals XY, which obviously is not true.
Right, but if it could, if it was, it's a potential that it could, but in this case, we're not making that claim. All right.
The theorem wrong.
So once again, today is all about following the patterns. Can you follow the pattern? So somebody give me a pattern.
XY to YZ.
I think that's the one I've given you.
Okay. About RT to XZ.
So RT to XZ equals what?
Equals RS to XY.
That'll work. Right, you just got to set up a pattern. All right. So today's just about following patterns. We're not done yet. We get one more. So let's see. The first one looks like a what? The first shape we did looked like a with
I don't know.
what kind of line? Yeah. So you got a triangle, and you got a parallel line to one of the sides, and it cuts the opposite, the one that it intersects, into proportional segments. The second shape is
Three parallel lines cut by two.
three parallel lines cut by two different transversals. Turns out that the transversal are cut proportionally. The third shape, not like any of these.
A two triangles now two. No.
And what did I tell you about looking ahead? You're gonna. It's like you're skipping to the end of the movie.
I'm not supposed to look at this. It's
Oh.
literally right under.
All right, you got me.
Wait, you can skip through the movie.
No, I thought I was looking at the book again. All right, so there is a triangle there, and although yes, I did draw it obtuse, doesn't have to be obtuse. It's just a triangle, and one of the angles is bisected, right? And then that segment intersects the third
Those are
side.
just two triangles. What do you need to construct on?
All right.
Okay, hold on. Wait.
So what we're trying to prove is another set of patterns that are proportional to each other. So watch what we're trying to prove. We're trying to prove that this to this equals
This. DF over DE.
this to this. So it's a completely different pattern.
We
Right.
could do it.
We're doing this to this, then I'm pointing to FGGE, is equal to FD. The way I remember it is I'm starting on the small one, and then I'm going to the medium one, then I got to go back to the small one and go to the medium one. Right? Or I'm starting on this side, the second ratio has to also come from a side on this one. If that makes sense. Okay? So this to this equals this to this. That's one way of saying it, but there's lots of others. Okay? The only side we're not going to talk about is DG.
Wait. What if we do a point?
If you looked at the proof
I didn't.
and you say this, then it kind of negates all this.
I didn't look at the proof. I didn't look
Pretty
at the
much
proof.
all of this, and I already said we're going to do it the way McKinley said to do it. McKinley, what was your suggestion from the previous one? I said hold that to the very end. Do what?
Extend to 2 points.
Which one am I going to extend?
F and K. Probably.
There's no K up there.
No, that's not K. That's E. Sorry.
So I want to extend
F
this
and E.
down here.
No, F and E. You extend.
That is
longer.
F and E.
Oh, well then G and F. I mean G and E.
Well, that's the same one.
No, you do it forwards, up like this.
Up
right?
like here?
No.
Do you mean DE?
Sure.
DE wouldn't work.
So if you did DE in this direction,
No, not like that direction. You do it forward like this.
Not? Well, I just did it in both directions.
All right, so you take E, then you put it down like this, not sideways.
In
Down.
any direction?
No,
You have an
straight
infinite
towards
number of
C.
directions.
McKinley, E is not a
Okay,
line.
let's go what he's saying. Let's extend E, but where are we gonna put that
Not,
point?
not E that way. You do it at an angle.
Why don't we just extend FD?
We can do it his way as well too. If we extend this one, what would be the logical place to put it?
So that would intersect FD.
FD, yeah.
So you're saying extend this until it intersects that?
Yes.
Okay, we got to add one extra thing.
So that is parallel to GD,
So what is parallel to GD?
the line EK. Or
So what I was trying to hopefully get McKinley to say is, okay, let's extend from E outward so that you create a segment that is to DG, and then extend FD straight down. Now the book does it easier, just simply says extend FD to a point, I think they call it X, so that XE is parallel to DG. That's literally what they do. Okay, so they say construct X KE parallel to DG and extend FD into the K. So it's literally what you just said.
Yes. So I'm right. And I'm
Well, eventually, you're
I
right.
was right the first time.
You were having us extend FE in some direction that none of us could understand.
I was trying. I know you're. I'm just ahead of my time. Because I always have the high ground. See how I do that?
No, you do not.
I have the high ground.
No, I have a
All right, and that's just basic construction. Okay, so we did all that. So what? What can we say now with our construction? What can we say?
Say a lot about this.
What can we say?
You can say 2 is congruent to 4.
Why would 2 be congruent to 4?
Because it's 2 parallel lines cut by a transverse.
So why would 2 be congruent to 4?
Alternate interior.
Alternate interior,
Right, 1 is congruent to 3.
because,
Corresponding
all
angles.
right, let's say both of those things. Let's say that 1 is congruent to 3, corresponding, and 2 is congruent to 4, alternate interior. Oh, I'm sorry.
Ah,
Before what you said was fine. They choose to, because we made this construction, now it looks like
8. Oh, well, we just had
it looks like
7.
7-3, right?
Just
Therefore, we
FG
could
over-
say
FG over GE equals FD over DK.
yes. Okay. And I've already stopped saying 7-3. Now we can say and it didn't matter the order. You say 1 to 3 and 2 to 4. 1 to 3. Why can't I say 1 to 2?
Because it's it bisects FDE.
Yeah. So we got this bisector right here, so we can
And then
say
you
that
say
as
2
well.
is congruent to 3,
Let everybody get caught up.
and you can also say.
And
4
that's
is
just
congruent
short
to
for
4.
corresponding. Corresponding and alternate interior angles are congruent. I didn't want to write the whole thing out.
Congruent to 4, and they say we're trying to
Is it weird that we use proofs to solve everything, but just a bunch of work?
It's not weird. It'd be weird to a caterpillar, maybe, but not to a human. All right, let's see if I can help Jack out.
And
What's that say?
1 is congruent to 2,
But this says,
4 is congruent to 2,
and that says,
1 is congruent to 3.
so what could you immediately say?
1 is congruent to 4, 2, 3 is congruent to 2. They're all congruent.
So what's another way of saying that?
Is 1 is congruent to 2 is congruent to 3 is congruent to 4.
In one statement.
1 is congruent to 4.
Is 1 congruent to 4? Sure is, because 4 is congruent to 2. But I could also say, so what could I say to really mess up this one?
1 is congruent to 3. 4 is congruent to 3.
How about we change a 1 to a
3.
3,
and a 2 to a,
4.
so what can I say?
Angle 3 is congruent to angle 4.
3 is congruent to 4.
that's what you
All
said.
right. That's just a whole bunch of substitution. Now, the big question is, what the heck was that going to do for us?
Well,
McKinley, look at the shape, and I just said that 3 is congruent to 4.
Oh, yeah.
So what?
It's congruent to 4, which means FK congruent to KD.
I just said that angle 3 and angle 4 are congruent.
EK. I can't see.
What's so special about 3 and 4?
They're parallel to 1 and 2.
angles can't be parallel.
Not parallel. They're something for one to
If let's just think on a really simple basis. I just showed that 3 is congruent to 4,
which means that
which means,
one is congruent to 2.
well, we already knew that because it's a bisector.
Yeah. Then that means GF.
Let's look at 3 and 4. If 3 is congruent to 4,
and
what do you have?
K is congruent to E. Yeah, 3 and 4. K is congruent to E.
Well, I've already given them a different name. I'm calling them 3 and 4. And by the way, E is not very descriptive.
Well,
If 3 is congruent to 4 on a really basic level, what does that mean to the shape? Girls? What? I got an isosceles triangle. Where's our isosceles triangle? It's that one, DKE. So if DKE is an isosceles triangle, McKinley, what can you say? If it's an isosceles triangle.
then
So is
Hold on, just focus on the isosceles triangle. If it's an isosceles triangle, what can you immediately say? Well, you could say,
4 are equal.
well, we already said that.
Yeah, they would equal the same thing, which means 2.
Forget all the other stuff. We'll just look at the one triangle. If it's isosceles and 3 is congruent to 4, then what's an isosceles triangle?
The big triangle.
That have,
Or 3 sides.
all triangles have 3 sides.
I don't know what you're asking.
What's an isosceles triangle?
The triangle.
That has,
You can grow bottom.
I'm not sure what you mean by that, but I think you might be on the right track.
Bases, sorry.
They don't have any bases.
Well,
Yeah,
their
what
bases
base?
equal. A base. The
Right.
2 numbers on the base are equal to each
What do
other.
you mean the 2 numbers on the base?
The angles of the base.
We already said that. That's literally what it says. 3 is congruent to 4.
Yeah.
What else can you say about isosceles
I
triangle?
don't know.
How many sides are congruent on an isosceles triangle?
3. 2.
Isosceles?
6. That's
It's 2. Which 2 sides are congruent?
3 and 4.
Those are angles.
Oh, B and A. Well,
2 sides. Give me their names.
E. No, wait.
E is a point.
Well, E and D or E and G. Or
Give me 2 sides.
G and D.
G and D are not even on the triangle.
No,
D is.
I said G and D.
Oh.
D and F.
Where's the triangle that's isosceles?
E, G, K, right? That's isosceles.
E, D, K is isosceles. So which 2 sides are congruent?
D and K, that's what
Those are 2 points. We don't say.
That's a side. That's the side DK. And it's,
Here are 2 things.
oh, it's just side.
What's the name of this one? Okay. Now what's the name of the congruent side? The name of it.
Green.
Right on my triangle.
It's 4.
Okay.
It's side 4.
D, E, and D, K.
It's-
Side is a segment.
Yeah, so segment DK.
That's 1. There's 2 of them.
DK.
D, K, and D, E. All right. They have to be equal.
That's what I said.
You didn't say anything remotely like that. All right. And by the way, notice I didn't say congruent. Why didn't I say congruent?
But they're not.
They are congruent.
Yes, they are. But it doesn't help you because then you can do substitution.
Why not?
Because then you can do substitution if you have an equal sign.
Because what I'm trying to do, the whole problem with this is what? It sort of looks like this with one exception.
Bottom.
I need to get rid of this DK. I need to turn the DK into a,
DE.
and I just did. So it's a substitution and you're done. Now it's hard to see the shape because we drew so many lines over it. What was the original shape?
The obtuse triangle.
It was a triangle. I never claimed it was obtuse.
It is obtuse though.
Well, I never claimed it was.
Yeah, it is.
Well, I didn't. Where does it say it's obtuse? Okay. All right. So it's a triangle that has
Numbers.
Exactly.
Angle by.
an angle bisector, and that bisector must. You got to be careful. Not all angle. Yeah, that's right. Okay. I was trying to think, is there occasion? So yeah, the angle bisector intersect another side and you get that basic shape. So what shape do you get? Yeah, it was a pretty tough one, right? You get that shape right there. And yes, it's generally drawn as an obtuse triangle, but it doesn't have to be obtuse. Check it out. If you put the angle bisector of F, would it not intersect the other side? If you have the angle bisector of E, would it not intersect the other side? The reason why they draw it as an obtuse is because it makes a nice, pretty diagram. So if you have an angle bisector, then it divides the opposite side into segments that are proportional to the other two sides. This one needs some explanation. I mean, like, you need to literally write down what's in yellow there. So which proportion does it give you? It gives you GF over DF, I'm sorry, GF over GE is equal to DF over DE. And all the other interpretations of that proportion. So I could say GF over DF is equal to GE over DE if I wanted to. But the key is you gotta follow the pattern. You gotta follow the pattern. And I do want to say, we showed you almost, well, not all of them, but almost all of the possible proportions for that first one. I never showed you them all for the second one. I'm not showing you them all for this one. But you've got to remember, there's way more that exists than just this one right here. The key to doing this for homework, for a test, is simply, they're going to set up a pattern, you follow the pattern.
Why did they choose D, E, F, G?
I don't know. I probably would have chose GF over DF, me personally, but they didn't.
I would have just did A, B, C, and D.
Oh, you mean as letters?
Yeah.
Good music joke we had there, guys.
Yeah, every good boy does fine.
Oh, good chocolate milk.
Maybe you're thinking chocolate because Miss West said every good boy deserves it.
What's the difference between fudge and chocolate?
I have
Because fudge is like
It's like fudge is like a specific like dessert.
How do you know you have fudge and not chocolate?
Well, fudge is like I don't know.
fudge is like frozen chocolate.
It's different.
Like fudge is like when you melt down
Fudge has
chocolate and you
other
freeze it.
things in it too.
Okay, such as.
It
So how do you know if you're eating fudge?
Why are you asking me
Does
such
it
a
taste
philosophical
different?
question?
Isn't it not a proof?
It's like tastes
It's
different.
Squishy?
Yeah.
So what happens when chocolate melts? Is it not fudge?
No,
And it's
liquid.
fudge, yeah.
If
It's
you melt it and then you
liquid
freeze it, it
chocolate.
becomes fudge.
No, either.
All I want is
I've heard of the words before. I'm
I
sure
want
I've eaten fudge in my life, but I couldn't not for the life of you tell you.
Fudge tastes different than just chocolate. Like if you were to eat a chocolate bar, it tastes
Well, I think most people would say eating regular chocolate. I mean, just chocolate. Wait, well, not chocolate. I was gonna say, I think it's officially called chocolate if there is sugar in it. Although there's baker's chocolate, it doesn't have any sugar in it.
well, why is it called chocolate? What
Exactly. It's called nasty, bitter. Right?
Dark chocolate.
All right. Today was all about following patterns. Let's see if we can do a couple of these. All right. Here we go. Do I want to do this, or do I want to find some that have variables? This will work. All right. McKinley, give me one pattern on question A right here.
X 14. X over 14.
Equals what?
X over 14 equals 6 over 6.
Could you solve that proportion?
Probably.
All right, Jack, give me one that involves the x's.
14 minus x over x equals 6.
Okay. Allie, give me one that involves the y's.
5y over 3y equals y over y.
Ooh, they only gave us one side.
What if you say 5y over 14 equals 3y over 14?
That'll work. Got the last one, Anna. Hey, there's no variable here. Oh, I know why. This was the original one, right? By the way, you could have used 6 and 10 on this side. That's why that didn't happen. Okay. I don't think you're going to be troubled too much with homework as long as you follow pattern and keep the pattern, you'll be fine.
But what if you're terrible at pattern?
Well, you're going to be terrible at the homework.
Good luck. That's all that he can help you with.
Ben, do you have any questions?
No, I do not. Goodbye. Have a nice day.
Well,
Can I eat donuts?
can you eat donuts? Yes.
Can I eat them in this class?
Can you eat them? Of course you can.
Goodbye, sir.
May I eat donuts is what you're asking? You may eat a donut if you bring me a donut. And then both of us will share the wrath of your fellow classmates for you not bringing up donuts for everyone to enjoy.
Then I will eat the other half.